Hi everyone, welcome to another LIC class. Today's class is going to be a review session for the upcoming exam. I'll give you the questions. I'll give you a few minutes to think on it. And the first person to solve it actually gets an extra point on their next exam. Before I start, do you have any questions about the exam and the material? Okay, let's dive into it. So for the first question, we want to determine the load current for the following circuit. RL is 15K, RI is 2.5K, and VN is 1.5 volts. I'll give you 1 minute. Has anyone solved it? Uh, we are looking for the current, okay? So if you can't remember what type of circuit this is, by the way, this is a transducer, voltage to current transducer. Just remember that the principles of an ideal op-amp. For an ideal op-amp, the input current is always equal to 0, and V positive is equal to V negative, and input current is equal to 0. So if input current is 0, and I have I load coming in, this is IL, the load current, and IN is equal to 0. By the way, IL is equal to IN plus IRI, according to the Kirchhoff's current law. And since IN is equal to 0, therefore IL would be equal to IRI. And again, V positive is equal to V negative. This voltage is equal to the negative. Therefore, this voltage, I'm going to call it V negative, is equal to V positive, which is equal to Vn. Okay. Now, what is the current of Ri? I'm going to use the Ohm's law. It's going to be V negative for this voltage from here to here, which is V negative. This is going to be its voltage, which is V negative, over Ri. And what is V negative equal to? It's actually equal to V positive, which is equal to Vn. So it's going to be Vn over Ri. And we learned that IRI is equal to IL. Therefore, this would be equal to IL or I load. And here we want to determine I load. So I load here would be equal to Vn over Ri. How much is Vn? It's 1.5 volts. How much is Ri? It's 2.5 K. Therefore, the result would be 0.0006 amp. Or in other words, it's going to be equal to 0.6 milliamps. If we were asked what is the maximum output voltage, Vmax, it's not asked in this question, but if in the exam we asked for the Vmax, it's going to be Ri plus RL IL, which is going to be equal to 2.5 K plus the 15 K times 0.6 times 10 to the power of negative 3, which is milliamps, which gives us 10.5 volts. The maximum output voltage would be also 10.5 volts. So 0.6, 10.5. Can I go to the next question? Yes. So next question, we want to determine the output current for the following circuit. RL is 50K, RI is 20K, RF is 5K, the input current is 20 microamps. Again, I'll give you 5. Okay, did anyone solve this? Okay, you need more time. Does anyone have the answer? Not exactly, but anyone else has the answer? Okay. So again, there's a very easy way to solve this. The easier way to solve this is that we already learned, I think it was in chapter 4, that this is a type of transistor. This is actually a current amplifier. And the equation for this current amplifier, I out, would be equal to IN times 1 plus RI over RF. Again, this current is equal to 0. These two voltages are equal. Therefore, all the current, input current goes through RI, and then RI plus IRF would be equal to I out. I did the proof for this, actually, this exact problem in the class. And the final equation that we have for this would be I out is going to be IN 1 plus RI over RF. I don't want to go through the proof again. RF is going to be the VA over RF, and IRI would be VRI over RI. We know that these two share the same voltage, because if this is ground V positive, then V negative here is also equal to the ground. Therefore, VRI is equal to VRF. And IRI is equal to VRI over RI. And IRF would be equal to VRF over RF. And we can replace this in this equation, and we get to the point that I out would be equal to IN 1 plus RI over RF. So simply putting it that equation, I out would be equal to IN, which is 20 microamps, times 1 plus Ri, which is 20K, over Rf, which is 5K. Therefore, I out would be 100 microamps. The only thing that you need to know in the exam is just remember this equation. This is a current amplifier, and just replacing that, we're gonna get I out, which is gonna be 100 microamps. Yes, this is just for this format. Yeah. By the way, IN is equal to IRI. So if I replace that, it's going to be IN plus IRF, going to give us I load. And I load again is actually equal to I out. So IN plus IRF gives us I out and so on. Any other questions for this? Can I move to the next question? So for the next question, this is 15K, and this would be equal to 60K. We want to determine the frequency response of the circuit. This is a 741 with a gain bandwidth product of 1 megahertz. Did anyone solve this? Okay. So to draw the frequency response, we need to know the horizontal, vertical, X and Y axis parameters. We need to know the gain and we need to know the frequency. So for the gain, this is an inverting amplifier. So for an inverting amplifier, the gain would be negative R2 over R1, which is going to be negative 60K over 15K. Or let's say the size of the gain gives us 4. So the gain is 4. Now we need to find the upper cutoff frequency. By the way, this is a low pass filter. We need to find the upper cutoff frequency. To find the upper cutoff frequency for the system, I'm going to call it F2. Is going to be the gain bandwidth over A noise. And A noise for the system is going to be A1 plus R2 over R1, which gives us 1 plus 60K over 15K, which is equal to 5. So again, the upper cutoff frequency would be 1 megahertz divided by 5 gives us 200K. So the upper cutoff frequency is going to be 200 kilohertz. And this is going to be our bandpass. I'm sorry? What? Yeah, this is the size of the 4. We don't care about the sign, as I mentioned. The magnitude is important for us. Magnitude is 4. Negative 4 just means when you have a negative, just means that the signal has been flipped or it has a 180-degree phase shift. But the gain, the magnitude of the amplitude increasing is 4. It doesn't change if it's negative 4 or positive 4. That's a good question, by the way. Can I go to the next question? Okay. So next question, we have 3 stages of 741s. We want to find the upper cutoff frequency. This is 25, this is 5, this is 15, this is 3, this is 10, this is 5. We want to find the upper cutoff frequency of the system. And we want to find the total gain. And does anyone have the answer for this? Mhm. So the total gain would be the gain of the first stage times the second stage times the third stage. All of these are non-inverting amplifiers. So for the first stage, it's going to be 1 plus 25 over 5. Second one would be 1 plus 15 over 3. And the third one would be 1 plus 10 over 5. So it's going 6 times 3. What is the answer? 108, yes. Am I correct? Okay. And the frequency, the upper frequency for stage number 1, I'm going to call it V21, is going to be 1 megahertz over its A noise. And since this is a non-inverting, A noise and the gain are going to be the same. So 1 megahertz over 6. For the second one, again, it's going to be 1 megahertz over 6. And for the third one, it's going to be 1 megahertz over 3. So the first and second is going to be 167 K. All of them are in K, by the way. And the third one is going to be 333 K. So which one is lower? 167. So this is going to be our lower cutoff frequency. And the total gain is going to be 108. I don't have time to solve another. Let me see. What time is it? 10:30. We have time to solve another quick one. So for this one, imagine this is 10, 2, 15, 3, 24. Same question, but different numbers. We want to find again, upper cutoff frequency and also the total gain. Did anyone get the answer? So what is the total gain? The gain of each stage, by the way, again here, the gain and the A noise are going to be the same. For A1, it's going to be a 1 plus 10 over 2, which is 6. A2 is 6. A3 is also 6. So all of them have the same gain. I'm sorry? 216, yes. F2 is going to be 1 megahertz gain bandwidth product over A noise, which is 6, gives us 167 kilohertz. Now, since all of them are the same, F2 of the system would be actually calculated using this equation. It's going to be F2 square root of 2, 1 over n minus 1. We have 3 stages, so n would be 3. So therefore, F2 of the system would be equal to 167 kilohertz times 2 in the power of 1 over 3 minus 1. And what was the result for this? What did you get? You haven't calculated this? 85. 85, thank you. So the upper cutoff frequency is 85 kilohertz. And the total gain is 260. So this and this. Okay. I think we are out of time. Our exam is going to be on Thursday. For the online students, I will post an announcement about the exam.